We'll go through some step-by-step examples of calculating the variance and standard deviation, just like we did with the MAD. But before we do that, I wanted to show you a quick demonstration of how the MAD, variance, and standard deviation are all able to show the amount of dispersion in the data. This demonstration will show you that the MAD, variance, and standard deviation all increase when the data has more dispersion or more spread. So here's the demonstration. Here's a made-up data set with 4 data values. The 4 data values are 3, 4, 6, and 7. The mean of these 4 data values is 5. If you added these 4 data values and divided the total by 4, the answer would come out to 5. So the mean of this data set is 5. If we subtract each data value by the mean of 5, we get the deviation of each data value. So 3 minus 5 is negative 2, so 3 has a deviation of negative 2. 4 minus 5 is negative 1, so 4 has a deviation of negative 1. 6 minus 5 is 1, so 6 has a deviation of 1, and 7 minus 5 is 2, so 7 has a deviation of 2. If we take this column of deviations and we just leave off the negative signs, we get a column of absolute deviations. And if we calculate the mean of the absolute deviation column, we get the MAD, or the mean absolute deviation. So if we add these 4 absolute deviations and divide the total by 4, because there's 4 of them, we get the MAD, which is 1.5. So this MAD of 1.5 is just the mean of the absolute deviation column. It's the mean of the 4 absolute deviations. If we multiply each deviation by itself, then we get a column of squared deviations. So negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 1 times 1 is 1. And 2 times 2 is 4. So we've just squared each deviation. In other words, we've multiplied each deviation by itself, and we've calculated this new column of squared deviations. If we calculate the mean of the squared deviation column, the answer will be called the variance. The variance is just the mean of the squared deviations. So just like how the MAD is the mean of the absolute deviations, the variance is the mean of the squared deviations. They're just the means of 2 different columns. So if we add these 4 squared deviations, the total is 10. And then 10 divided by 4 is 2.5. So the variance, or the mean of the squared deviations, is 2.5. If we put the variance of 2.5 under a square root sign, and we get the square root of the variance, then the answer is called the standard deviation. The standard deviation is just the square root of whatever the variance equals. So the square root of 2.5 is 1.6, so the standard deviation of this data set is 1.6. So we've just found out that this data set right here has a MAD of 1.5, a variance of 2.5, and a standard deviation of 1.6. Now what I'm going to do is I'm going to increase the amount of dispersion in this data set to show you that the MAD, variance, and standard deviation will all increase. What I'm going to do is I'm going to drop this 3 down to 2, and I'm going to raise the 7 up to 8. By dropping the lowest value by 1 and raising the highest value by 1, I'll increase the amount of dispersion in the data, and then that'll cause all 3 of these values to go up. So I just increased the amount of dispersion in the data because, like I said, the 3 went down to 2, and the 7 went up to 8. Now our MAD, variance, and standard deviation have all gone up because, remember, before the MAD was 1.5, and now the MAD is 2. the variance was 2.5, and now the variance is 5. And the standard deviation was 1.6, and now it's 2.2. So all three values have increased because of the fact that the data now has more dispersion. Now let's think about why. Let's think about why the higher dispersion in the data caused these three values to increase. Well, back when this number was a 3, then this number was only, this lowest number right here was only 2 away from the mean. It was only 2 below the mean of 5. So it had an absolute deviation of 2. And this highest number of 7 was also 2 away from the mean of 5. So it also had an absolute deviation of 2. But now, since I've changed the lowest and highest numbers, the lowest number right here is now 3 below the mean of 5. It's now 3 away from the mean of 5, so it now has an absolute deviation of 3. This highest number, which is 8, is now 3 away from the mean of 5. So now that the highest and lowest values are 3 away from the mean, instead of just 2 away from the mean, these two absolute deviations right here have gone up. Instead of being 2 and 2, they're now 3 and 3, which means that the total of the absolute deviations is bigger. The total of the absolute deviations used to be 6, and 6 divided by 4 was 1.5, but now the total of the absolute deviations is 8, and 8 divided by 4 is 2. So since these two absolute deviations have gone up,